All right. So we're talking today about architectural drawings. And if you go to the assignment, you have the ability to download this DWG file of the Stevens Center. So go ahead and do that now, and then we can play with it a little bit. Okay, so this is similar to the kind of file that you would get from a technical director. Okay. The one difference here, the one thing that I have done for you is I have changed the color of all the layers to white. So they're not, because when you get it from the TD, it will have tons of different layer colors and stuff like that. And the reason that that I've gone and changed that is it's, for some of the stuff we do, it's helpful for us to utilize color in the actual plot, and most people don't do that. So I've gone in and I've changed that. It's easy to do. It's easy, you just select all the layers and change the color, and they all get the same color. So that's the one difference about this that you wouldn't normally see. But this is a theatrical architectural drawing. True architectural drawings have quite a lot more detail than this, but this is for the purposes of putting a show in this space. This is pretty typical for what you're going to get. There are a couple of things I want to point out here. When people draw these things, they have, just like so far when you've drawn things, you have to decide where your origin is going to be, right? You're drawing everything relative to 0, 0, right? And so far that location of 0, 0 has been fairly arbitrary, right? It's just been this thing that exists at some place that doesn't really matter, but you just draw everything relative to that. Well, when you're doing something like this, you have to make a very conscious decision about where that's going to be. And it's pretty common practice for that to involve the intersection of two imaginary lines. And those two imaginary lines are called the center line and the plaster line. Okay, so if we look here at this is called the plan view, or ground plan view. And this is like, okay, we cut the ceiling off the building and we're looking down at it from the top. The center line is this line that is like if we cut the building in half and opened it up, that center line is the line at which we cut it in half. So it's this line that goes down the middle of the building. And it's usually in like a proscenium space like this, the center of the upstage wall and the center of the back wall of the audience area, right? You're just like cutting the building in half. It's called the center line, the center of the space, okay? And then there's this line called the plaster line. The plaster line is a term that applies mostly to proscenium theaters, but this is the plaster line. And the plaster line is the upstage edge of the proscenium arch wall. Okay, so this wall here, that's the proscenium arch opening, and the upstage edge of that is what's called the plaster line. Okay, and the plaster line more or less is like the difference between public audience area and backstage area. Right? That's the line between those things. And often we break that line, and we do sometimes shoot the show out past the plaster line, but we very rarely let the public into the other side of the plaster line. But we will sometimes push the show out past there. Now, in a black box theater like Catawba or something, you essentially have two center lines. There is no plaster line in Catawba. So instead, it's two center lines that intersect in the middle of the room. But this spot where these two lines intersect, that is going to be your origin. That's going to be where you draw everything relative to. And then this side of it, this is what's called the section view. And this is where, okay, we actually cut the building in half on the center line, and we're looking at it from the side now, okay? And in this case, your origin is the plaster line, which is this line, okay, the upstage edge of the proscenium arch. And then the other part of that origin is going to be the level of the stage floor, okay? That would be the other axis of your origin. Now, here's the important thing, and this would have been very helpful to you on the first project, but I purposely didn't show it to you then so that I could show it to you now and have it make a special kind of sense, okay? Did you know that you can move your origin, and or in other words, you can move your UCS in AutoCAD? So in order to draw these four different views, the first thing I want you to notice is that they are lined up. So if I do a construction line, there, you will see that, oh, it doesn't quite, it's a little off, isn't it? So what's supposed to happen is that construction line is supposed to line up with that plaster line. Let's fix it real quick. There it goes. And that, okay. So there the plaster line lines up on all three of those drawings. Because even in plan view and section view, the plaster line should be in the same spot. And then the other construction line that I draw is from here to there. Now in this view, the plaster line should line up with the stage floor. And it does, okay? And when you're making these kind of drawings, that's very important to keep those lined up, because it really helps you when you start moving your UCS around. This vertical version of the plan is just like an extra that helps you kind of just see the relationship of things, but it's really not necessary. You're going to do most of your work down here. But when you make these drawings, which you will probably never draw a theater, as a sound person, that's usually not your job. Somebody else is going to draw the actual space, and they'll give you the drawing and you'll interrogate it a little bit. But when they draw it, they're moving the UCS around all the time. So let's just figure out, where is the origin right now? Well, let's find out. I'm just doing L line, and I'm going to say 0, 0. And okay, looks like it's there. Okay, that's where it is. But when you draw these, you're going to move it. So type the word UCS. It says specify a new origin. So let's say I want to go and work on this plan's view. I'm going to put the origin on that intersection of center line and plaster line. And then it says specify a point on the x-axis. Well, it kind of depends where you want this to be. But for purposes of this assignment, you are going to want your X to be pointing out towards the audience, and your Y pointing off stage left. Okay, so I'll show you this again. So specify the origin. There, X wants to point out towards the audience, so I line that up with the center line. There's X, and Y goes up here, and there we go. So now that point is my new origin, and I can prove it by just starting a line at 0, 0, right? And now that line is starting there. Why is that valuable? Well, because if you notice in the assignment I'm giving you X, Y, Z locations for where you're going to draw things in this room. And depending on where it needs to be in the room, it's going to make more sense to draw it on one of those three views: the section view, the orchestra level plan view, or the balcony level plan view. And I am giving you X, Y, Z coordinates for the room, not the drawing. And so you were going to need to move your UCS around a little bit sometime to get this in the right spot. So if you realize, oh, I have to draw something on the balcony view of the plan, then you're going to want to move your UCS down to that spot, so down to this drawing, so that you can now draw down here and have your coordinates mean something. Okay? Now, if you need to draw something in the section view, you're going to need to move your UCS up to there. And here I'm going to put it at the origin of plaster line and the stage level. And where is X? Well, X should still go ahead and point out towards the audience. And in this case, you're going to use Y as a stand-in for Z, because Z is the third axis that is basically vertical in real life. Okay, because this is the full version of AutoCAD, there is a Z-axis available technically, but you know, we're really doing a 2D drawing here, and so we try to stick with X, Y. So you're going to use Y as a substitute for Z in the section view. Does that make sense? So when you see a Z coordinate, that's only means something in the section view, and ultimately it's going to be Y that's going to be telling you where Z is going to be, just because of the way that this works. It is possible to get it to be a true Z, but that's not really something that is important to do. So I think, any questions about UCS? Does that kind of make sense? So you have to move it around a bit. The other thing that happens is, you know, technical directors and carpenters and stuff, they really like to use architectural units. And what I mean by that is, like, if you look at the sort of coordinates down here at the bottom of the screen, it's like, okay, this is 19 feet 4 3/8 inches. Well, they like to draw that way because that's what their measuring tape says when they're in the shop building the real thing. And they pull out the tape measure and they got to figure out where to cut with the saw. They want the drawing to tell them something that they could pull up on their tape measure. And very few carpenters in the United States have decimal feet tape measures. Such things do exist, but they're very uncommon. I mean, outside of the US, it would just be a metric tape measure, and that would make a heck of a lot more sense. But you know, we have this weird measuring system here in this country that we're very attached to for unfathomable reasons. Other than it's just we went down that road a long time ago, and it'd be really annoying to have to change it. A lot of things would have to change. It would be really frustrating. So we just like stick with it for some stupid reason. Well, that's the stupid reasons, because we're lazy and it would be a pain to change it. But for our purposes, and mostly this is about connecting to some of our other tools. But most of the tools that we use for plotting loudspeaker directivity, like Ease or ArrayCalc or Sound Vision or Map or something, all work in decimal values. Okay, and we do our math in decimal values. And so for us, you know, we never need to put a tape measure to anything. You know, very rarely do we actually plot a tape measure to do our thing. Only maybe when we're like flying out a cluster or something do we use a tape measure. So we tend to, our lives are a lot easier if we're drawing in decimal feet, okay? So what I want to show you is how to scale a drawing like this into decimal feet. Because right now, remember, at the beginning of the semester I said that AutoCAD is unitless, right? It just draws in units, and you just slap a label on those units. Well, when you see a drawing like this that comes from like a technical director, and you see these kind of measurements, I guarantee you 1 unit equals an inch on this drawing. And in our world, we really prefer 1 unit to equal a foot. So we have 2 problems with this drawing. One is it's in architectural units, but the other problem is it's drawn in inches, not feet. So we need to both change the units and we need to scale it. All right? So I will show you how to do both. So the first thing you're going to do is just type units. And it pulls up this. And changing the drawing units is easy. You just go from architectural to decimal, and you decide how many zeros you want to have after there. 3 or 4 is usually sufficient. For purposes of this assignment, I'm pretty sure I'm giving them to you. Oh yeah, I'm giving you in 4 decimal places, so you should have that precision. Okay. And then for insertion scale units, we're going to change this to feet. Not super important unless you're going to import other drawings into here, but just to remind yourself that you're in feet. It's just this is effectively a note to self. That really only means something to AutoCAD when you import another drawing. But go ahead and change that to feet just to remind yourself that that's what you're going to be in now. All right, so now we're in decimal numbers. Okay, but if you measure something, well, let's go measure something that we think we know how big it is. Like, I don't know, the width of this doorway. Okay, so there's a command called MEA, measure geometry. So MEA, enter. And you can kind of hover your mouse over an area and it'll kind of give you some dimensions. So it's saying that this thing is 36 wide, 95 tall. Well, okay, that can't be feet, right? That doorway is not 36 feet wide. Okay, so this is just a quick check. Just because we changed it to feet in units does not mean that the drawing is now in feet, okay? It's still 1 unit equals an inch. So I believe 36 inches, that sounds right. But it's not 36 feet. So we're not done yet, is what I'm saying. So let's escape out of that. Instead, we need to scale this. So let's do that. You're going to type the word scale. Enter. Select objects. Well, what objects do we want to scale? All of them. So literally do A, enter. Does that not work anymore? Doesn't work anymore. All, enter. There we go. They got rid of the A. All, enter. And it just selects everything. And then enter again to get out of the select. Specify base point. The base point is from what location are we scaling? Now, because we're scaling all, it doesn't really matter. But if you're scaling some, then the base point matters immensely, okay? But in this case, it doesn't really matter. So we'll just type 0, 0, wherever that happens to be. And it says specify a scale factor. So how much do we want to scale this by? Anybody got any guesses? 1/12, exactly, because they're 12 inches in a foot. We need to squeeze 12 units and turn 12 units into 1 unit, right? So I'm going to literally type 1 divided by 12. 1/12 and hit enter. And everything just got a whole lot smaller. Did that work? So now I can do zoom extents and it zooms back up. And now let's go measure that same doorway. Oh, look, it's 3 even. I believe that's a 3-foot door. That makes a heck of a lot more sense, doesn't it? Okay, did that work for everyone? Yeah? Okay, remember that process. You're gonna have to do that a lot. because you're going to get drawings from other people, and they're going to be in inches, and the units will be architectural, and you were going to have to convert it to decimal feet. And that is how you do it. Change the units, and then you scale 1/12. And now we're in decimal feet, and now we can do stuff. Okay, any questions about that?
About that exactly.
What's that?
Possibly something that you
Yeah.
might get to in the future.
Okay.
Is there a way that we can import the layers from our template and the textiles into this document so that we don't have to recreate
Ooh.
all of them?
Interesting.
Or is the best solution just copy this and put it into a document that we've made?
Yeah. I think the answer is both are possible.
And they both suck to do.
Yeah, I don't know that I've ever really. I'm sure I've done it before, but off the top of my head, I can't remember how to do it to actually import text styles. But I imagine it's probably possible. But I've never tried to do it. Or if I have, I don't remember. So what I usually will do is what the other thing you said, which is that I've got my template, right?
And you'll just copy this.
Yeah, and I'll just once I've scaled this appropriately, I'll just select these things, copy and paste them in. They're just lines, and then they're in my thing. So that's usually how I would do it. But I'm sure there's a way to do that. It's just not something I entirely remember how to do.
Yeah.
But we could look that up and figure that out if we really wanted to.
It seems slightly more complicated than I think I hoped it was, but it is possible, according to me.
Yeah, I think it is possible. But anyway, yeah, good question. So, all right, there you go. There's our drawing. We now have scaled, and now the measurements will mean something. So now let's take a look at what we're going to create. So the assignment here is to create a loudspeaker plot. Okay, and I have given you some examples here of what ultimately your final product is likely to look like. Okay, now the point of this drawing, and this is the most common reason that we will interact with an architectural drawing, is because we have to somehow communicate where the loudspeakers are going to go. There are two main reasons. Well, there are two important bits of information that we are trying to communicate here. That may not be totally obvious. There's a third thing that I hope is very obvious, but we'll get there. The first one that may not be obvious is, where does this go? Where does this thing go? I'm going to put a loudspeaker in it. Where does it need to be in the room? Okay, that is one of the things you're trying to communicate with this drawing. I'm going to put a loudspeaker in this room. Where exactly does it need to be? Generally speaking, this is measured based on the front center of the cabinet. Okay, generally. Every once in a while you'll encounter some other variants of that with other programs and stuff, like for loudspeaker plotting and stuff like that. But generally it's the front center, okay? So you need to draw a box that says this is where it goes. The second bit of information is, where does it point? Because as you will learn in the sound system design class, most of the loudspeakers that you will use in your life do not distribute sound equally in all directions. Okay, they are biased towards a particular direction, which is good. It's an important tool that we have at our disposal to make the sound do what we need it to do. So that's great, and we need that. And we spend a lot of money to get that right, okay? But because of that, it usually matters a lot where you aim this thing. Okay, it has to point somewhere, and you need to know where it's going to point. So that's the second bit of information. Where does it point? So where does it go, and where does it point? The third thing that I hope is obvious is, what is it? Okay. What is this thing? What is this box that I've drawn on this drawing? Okay. Hopefully that's obvious. You need to communicate that. What is it? Okay. But some people miss that. They forget to label it. Say, what is it? There's a fourth bit of information that some people try to cram into this drawing. And I am, in the camp of you don't need to communicate this part. But there are people who disagree with me on that, and that's fine. But the fourth bit of information that is important is, how does it get there? Okay? And this answering that question involves rigging and sometimes carpentry and stuff like that, which are, none of those things are really in our area of expertise. You're going to learn a little bit of rigging, hopefully. If you take that class is, in our new curriculum, that's becoming an elective, not a requirement, because mostly because we have to, I'm not qualified to teach it. And therefore, we have to have somebody else teach it from technical direction, and so you're like trying to get into a class they're already teaching for other reasons, and maybe you can get in, maybe you can't. So
maybe it's scaled up very hard.
yeah, or it's like they're telling you like 10 times more information than you actually need,
Okay, maybe
right?
Everybody else in there's like
Yeah,
scenics person.
yeah. You guys taking it right now?
It's so hard.
Yeah, it's hard. It's a lot. There's a lot, but
And there's so much stuff that me and Jasmine are like, we know absolutely nothing.
Yeah.
Scale this down to be like you're talking to a baby, and he's
Right.
like, okay, and then he's still
Yeah.
way above us. And I'm like,
Yeah.
no, you're using words I've never heard in my life.
yeah, there's a lot to that, right? Putting heavy things in the air without dropping them
We have
is,
to create a calculator for next week.
yeah,
I have to make a calculator.
Yeah.
I'm so scared.
it's hard. There's a lot to that. And the stakes are high, right? The stakes are very high when it comes to rigging, because if you mess up, people can die, and so you really don't want to mess that up. So we don't need to be experts in that, okay? There are other people who are experts in that. What we need to do is we need to know when to get other people involved. We need to know that. We need to understand the line between what can I do myself that is very low risk, and at what point do I need to get someone else involved? And so that's one thing that we need to know. We also need to be able to know enough to look at something and be like, does that look right? Does that look safe? Should I get someone else to look at that? And that's the other thing that we need to know, because sometimes we'll come in. I've gotten so many different places where I've walked into a room and I'm like, whoa, I can't believe that thing is still up in the air, right? And it's like, I'm gonna get someone to look at that. So this is all by way of saying that, yes, you do have to figure out how to get the thing to that spot, but maybe that's not what needs to be communicated in this drawing. I would argue that's a different drawing. The how does it get there is a different drawing, and you are probably going to collaborate with somebody on that who knows a lot more about this than you are. Or at least you will draw it based on your limited understanding, relying very heavily on the manufacturer of the loudspeaker and how they recommend to rig it, and then you're going to have somebody look at that drawing who knows about rigging, and they will fill in some gaps for you. And that's typically how I have handled it. I know enough about rigging to know when something's wrong, and I know enough about rigging to know more or less how to safely put something in the air, like a loudspeaker, something simple like that. But I never do it all by myself. I will always, before it ever flies out, I will get someone else to come and look at it. Whoever's the rigger on the project, like, will you come and look at this before I take this 30 feet up in the air, and just make sure I haven't done anything stupid. And they will do that. they will gladly do. It's their job to do that. So I would argue that that's not what this is about. That's not what this drawing is about. And therefore, you don't have to, if you can accept that that's not what this drawing is about, then you can give up on a couple of things. And one of those things is scale. If this drawing doesn't have to be about how does it get there, then the actual scale of the box does not have to correspond with real life. You don't, because some of the things that we put in spaces are tiny. You know, some of our little speakers are tiny, and if you draw that on to scale in a room this big, it's going to be this little teeny tiny dot that you can't even see. And I think communicating where does it go and where does it point is the important part. And having an invisible thing does not communicate that important information. So sometimes I will draw the box representing the loudspeaker physically larger on the drawing than it is in real life, just so I can clearly communicate the part that's important, which is where does it go? The how does it get there part is a different drawing, and that one absolutely should be to scale and relative to all the architecture and all the things it has to be to, and the steel and all that jazz. But I am of the camp that this drawing does not need to accomplish that. And therefore, I think it's okay for the box to not be the exact same size, scale-wise, as it would be in real life. If you need to draw it a little bit bigger to make it visible so that it's very clear where it goes and where it points, then you should do so. Again, not everyone agrees with me on that, but that's how I feel. And I'm in a position where I get to have opinions like that, and I don't have to care whether people agree with me or not. But someday, you know, you will work for somebody else who will have a different opinion, and that's fine. If they have a different opinion, then do it their way, right? But if you're working for me, I don't care. I would rather just it be crystal clear where it goes and where it points, and then we sort out later how it gets there. Okay, that's my camp. So if you work for me, that's the story. So if you can let go of that idea of how does it get there, then you can let go of this idea of scale. And if you can let go of this idea of scale, a lot of things get a lot easier about this, okay? And so you will notice that in the assignment, I have given you 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 loudspeakers and some information about them. So this is what it is. Balcony left D&B E0. This is where it goes, and this is where it points. And I'm giving that to you in XYZ coordinates. Okay? So your mission is to draw that. So let's start with this first one. The center cluster top D&B Q7. Okay? Well, so the first thing I'm going to do is I'm going to go to the section view. And the reason I'm going to go to the section view is because the Y is 0 on this, which means it is sitting on the center line. So I'm going to start with the section view. So I'm going to go to the section view, and I'm going to move my UCS to that spot. So UCS, enter, and then I stick it there, draw that point on the X, and accept the Y, and there we go. So then I'm going to just go in, and there's this, first of all, I'm going to make a layer for myself that's going to be called sound JTR CC for center cluster. Okay? Again, trying to come up with a name that no one else will ever use. And I'm going to pick a color for that, but I'm going to use a non-standard color because the standard colors look really good against a black backdrop. They don't necessarily look good against a white backdrop, which is what happens when you plot this thing. And so I'm going to go in here and find a color that I can see on a black background, but will also look not terrible on a white background. So I'm going to do this slightly rusty red color, okay, for this layer. And then I'm going to make that my active layer. And then I'm going to use this tool called point. And you just type P-O-I-N-T, point. Specify a point. Well, so this is where you just type some coordinates. And I am going to type 14.6446, comma 39.6097. Okay, so 14.6446.
Jason, can you slow down for a second? What's the name of the layers?
Anything you want. It just needs to be a name that no one else will use.
Well, what is the layer going to consist of?
In this case, this is the center cluster.
Okay.
So I'm adding that to the name, CC. That's my shorthand for center cluster.
Okay.
But you are the only person who is ever going to see this layer, and it only needs to mean something to you. So call it whatever you want. So first point is 14.6446. And then the next point is 39.6097. And then I hit enter. And it puts that little thing there. See that? That's the spot. That's where it goes. Now, it is possible to format those points. These are mainly just like drawing aids, okay? So, let's see, is it? I'm trying to remember what the keyboard shortcut is for that. But you gotta, if you want to change them, you got to format point style. Oh, P type, that's the command. So it's P type, and it'll open this up. And so if you want yours to look a little bit different, you can change what they look like. And I prefer, you can do relative, set size relative to screen, and that way that the point will always be the same size no matter how much you zoom. Or you can do absolute units, which is what I prefer. And I can just say how big I want this to be, and you can decide how big you want it to be. Right now it's set to 1 unit. If I make it 2 units, then it's just bigger. Okay? So whatever you want is fine. But that's where the thing's going to go. So here's what I'm going to do. I'm going to just draw a little rectangle. That is, you know, approximately, I mean, this little box in real life is 2 feet tall and about 1 foot deep. So, you know, you just want to, you don't need, again, this doesn't need to be specific, but you get into that neighborhood. Maybe about that big. Okay. So I draw the little box, and now I'm going to hatch it. So make it, I'll do a solid hatch, and I'll change the color to by layer. And then I click inside there, and now it's filled in. See that? Everybody with me? Anybody need to catch up?
No, I still haven't been able to make my point. It's not showing
Oh, you need help?
up. Yes.
Okay.
How do I put the right layer on it?
Oh, yeah, you forgot to make that your active layer. So with it selected, just go up here where it says 0 and select your layer. Did you not make a layer?
I did make one.
Okay, and so that's fine. So say hit enter. Oh, it's got hit enter. So the.
Oh, gosh.
Oh wait, no, there it is. It's up there. Okay, so change the color of it. Okay, there you go. So now with that selected, you can go up here to that 0 and select your layer. Now there you go.
So what was the box that have to make this?
So rectangle. So you just have a rectangle, and here, but the real thing in real life is 2 feet tall and 1 foot deep. So you want to just be in that neighborhood.
In the normal snapping.
Okay. So go ahead and draw your box, and then I'll hatch it, and then we'll show you what's next. Okay, so go ahead and hatch it now. Yeah, do solids and change the color to be bilayer. There you go. Perfect. Okay. So now we got to move this to that spot where it needs to be. Okay? So here's what you're going to do. Under your object snaps, right click on object snap down here and turn on node snapping. Why is it called a point in one place but a node in another place? I don't know. It's been that way for at least 20 years. Doesn't make any sense, but there you go. A point is also called a node. Those are interchangeable terms in AutoCAD. So you turn on node snapping, okay? And once you have node snapping on, you are in business. So I'm gonna do M, enter for move. I'm gonna select the box, enter. I snap to the midpoint of the front side of the loudspeaker, click, and then I snap to the point that I drew, click, and now it is in that spot. So I have accomplished part 1. Where does it go? Now I need to accomplish part 2, which is where does it point? Where does it aim? So the aim point here is 97.4036 on the X and 50.1855 on the Z. So I'm going to draw another, in fact, just to make my life a little easier, I'm going to move this down here, and I'm going to resize my window so I can see this information in one spot. There we go. So I'm going to draw another point now. So I'll type point, and I'm going to type 97.4036 on the X, comma 50.1855 on the Y/Z. Enter. There's the point. See, it showed up right here in the back of the balcony. Okay, that's where it points. Everybody got that far? Okay. Now what I got to do is I have to rotate this box so that it is angled towards that spot. And so here's how I'm going to do that. Watch very carefully. Everybody watching? Are you ready? Watch, or you're not going to know this. I'm going to type rotate. R-O, enter. Select objects. I will select the box. Enter. Specify base point. The base point will be the front center. Specify rotation angle or copy/reference. You want to do reference, so you do R, enter. Specify the reference angle. I am going to do the front to the back at that midpoint. Oh, sorry, hang on. No, I did that wrong. Rotate, select. I did it backwards. Specify base point, the front. Specify the rotation angle, reference, and you go from the back to the front, and then this thing will spin now. You see that? How it'll spin on that axis? And now I can go up here and I just snap to that point And now that thing is pointed that direction. And then I just draw a line from that point to that point to make it super clear. And then it's done. I can delete that node now over here. You go ahead and leave this one, just because there's nothing else visible to indicate where it goes. But you can, so I'll leave those in case of my drawings, just because I need something to show up like that's where it's going. Okay, there you go. I did one. Look at that. Questions about that process? Okay, so now I gotta repeat this down on the plan view. Well, because the aim point is in the balcony, I'm gonna use the plan view that includes the balcony, the full balcony, which is this bottom one. So I'm gonna move the UCS to that drawing and orient it thusly. And now I'm going to draw another point. And this will be at x of 14.6446, comma 0, because it's on the center line. There's the point. See that? So now I just do the same thing again. I'm going to do a rectangle. In this case, the box is like a 1 foot by 1 foot square, but that's going to be a little small. If I draw it the way, it's really a trapezoid in real life, but I'm not going to draw that. So I'm going to make it a little bit bigger just so that it's not crazy tiny on this drawing. So I'll do it about like just that. And then I will hatch it. Because again, we're sort of assuming that scale doesn't really matter for purposes of this. It's more important that we can see it clearly. And then I can take the box and I can move it to that spot. And then I need to put in the aim point. Oops, I didn't quite snap to the right place there, did I? There we go. So now let's put in the aim point. So I'll type point, and the aim is 97.4036, comma 0. And there it is. So I'm aiming this right at the front edge of that spot booth. I don't have to rotate the box in this scenario because it's already pointing that way, so I just draw my red line from point to point. And then I can delete the insertion point for the loudspeaker. Okay? And then what I would do is I would go and I would make the label. So I would either use the text styles I already have, or I'd recreate my text style, and I would put that label, center cluster, top, D&B, Q7, and I would label it in both views, plan and section. Okay? And that's it. That is basically the idea. Now, I have included these examples not to say, these are just PNG files, these aren't CAD files, I mean they came from CAD files, but I don't necessarily want you to do exactly this. This is merely an example of what these drawings look like when you're done, okay? So I don't want you to copy these exactly. I don't care if you use the same colors. I don't care if your boxes are the exact same size. I don't care if your labels are the exact same size as mine. I think actually my labels could probably be bigger. This would be clearer if they were bigger. You will notice that even in this example, the center cluster aim point is not super accurate in the plan view because I put it on the orchestra view, and the top one really aims to the spot, but I really should have it down here so I can represent that aim point up there. So there's a couple things about this. I don't want you to read too much into these examples. The reason I included these examples is just so that you have an idea of what the finished product ideally will look like. Okay, but I don't want you to copy these drawings because these are not perfect. There are problems. I'd like you to do something a little bit better than this. Okay. Now the other thing you will see is that I have different layers and therefore different colors for different groups of loudspeakers. Okay, so like my center cluster is red, my balcony fills are this like lavender color, my front fills and under balcony fills are green. They're the same color because they're the same kind of loudspeaker, the D&B E3s. Okay, so that's how I dealt with it. As I just sort of, if they were the same kind of loudspeaker, I made them the same layer and the same color. Some people will say, well, I will group them in systems. So front fills are one layer in color, center clusters one layer in color, balcony fills are one layer one color, under balconies are one layer, so on and so forth. But your mission now is to basically do that for all 12 loudspeakers. And this whole coordinate thing, this is real. This is what comes out of a program like Ease or ArrayCalc, is you get coordinates like that. And it'll tell you, oh yeah, here's X, Y, Z, where the thing goes. And now you have to draw that. And here's X, Y, Z, here's where it intersects with the audience. There's your aim point, okay? So that's where these numbers come from. That's why they're so weird, oddly specific. It's because they come from the software we use to figure out where to hang and put loudspeakers, okay? So that's your assignment, is plot it in there and turn in that DWG with all that stuff. Any questions? Shouldn't be too tough. This is an opportunity for you to get used to navigating around an architectural drawing, moving your UCS around a lot, which you're going to have to do, understanding what the plan view means, what the section view means, and while you're doing that, you'll generate an actual useful drawing of loudspeaker plot. Okay? There you go. This should not take you a long time. Should be, compared to like the last project, this will be easy. Hopefully.
So for the center cluster,